So we're starting here on page 15, which we did in class. It's kind of hectic with the Play-Doh, if you remember, so I'm not sure how great your pictures ended up being. And this is one time where at least some of the pictures are super important that you get. So with principle of original horizontality, which is the concept that layers were originally horizontal. Again, it's a stretch with the name, I'm sure. So if they were originally horizontal, if you find them tilted, it means they were tilted after they were laid down, after they were deposited. And all you needed for the drawing for that one was nice horizontal layers. So that was all you should have had really for the first set of drawings. Yeah, but I remember it was kind of chaotic with everybody sitting in their groups. So I just want to make sure these first three, I'm sure you guys have just fine. It's the last two I want to make sure are not awful. So then with principle of superposition, again, that's a super easy concept that says when there are layers, the oldest is on the bottom and the youngest is on top. So it should, again, still be basically the same picture, just with a couple of labels. So if your label or your picture doesn't have labels, add that. Faulted strata was just broken layers. So again, not an overly complicated drawing, just showing that the layers can be broken, but still match up with the oldest being on the bottom and the youngest on top. And these would match up across the break. The intrusion is the drawing that I want to make sure you guys had and understood completely. So an intrusion is when hot magma squeezes up through the layers and touches the rocks around it. And we've talked about this actually at least one other time this year. Then when hot magma touches the rocks around it, it will burn those rocks, kind of like fire burns a marshmallow. So in that picture, so again, you still had your four same rock layers, but in that picture, you should have had a blob of hot magma that came up and squeezed in between the rock layers. That is the intrusion. Notice that the lava does not go to the surface. So if yours comes out of the ground like a volcano, you do need to fix that. It still needs to be underground. But the last part of this is the burning part that needs to be shown on, can we just sit still or leave? Okay. So the hot magma, we need to show that it burns the rocks around it. And we need to show that with these little marks that are supposed to come off the lava, kind of like hairs on a woolly caterpillar. So they come up and they're just these little hatch marks. Those represent contact metamorphism. They're showing that these layers surrounding the intrusion have been changed, or morphed is the official word. So the little marks represent contour, or no, they don't, contact metamorphism. And then the last really important takeaway piece from last Friday was an extrusion. And when an extrusion, again, it's hot lava that comes out of the Earth's surface now, and it'll sit on the Earth's surface, just like this blob of magma is right here. Again, with the contact metamorphism, you have to show that I did it again, contact metamorphism changes or burns the rocks around it. So you see all those little hairs again on these layers of rock. The important thing is that you added the contact metamorphism. So you see that the contact metamorphism is burning everything it's touching. What do you notice about along the top here? It's not touching anything. So is there any contact metamorphism on it? No. But then 1,000,000 or 2,000,000 or 5,000,000 years later, what's going to happen to the lava in that time? It's going to cool, and it's going to harden, and it's just going to be solid rock. Right. And then if we another layer forms on top of it. Okay, good. So we did talk about this. Okay, so nothing happens to it on the top. This is still, even though it's covered up, it's still an extrusion. And the regents will say, how do you know that this layer or this was an extrusion and not an intrusion? And how can you tell that this is an extrusion and not an intrusion? Because there's no contact metamorphism on the top. So, and I do remember doing this now. So if I had labeled these A, B, C, D, E, sorry, and they asked what's older, the extrusion or layer E, which layer is older? A is the oldest, but that wasn't my question. What is older, the extrusion or layer E? How do you, and then they'll follow that up with, how do you know? Because we did just go over it, Logan, because there is no contact metamorphism on E. So you know that the extrusion was there, cooled and hardened, and layer E formed on top of it. All right, so that leads us to these 4 questions, which are 4 questions that might be out of some of your comfort zones. They each are different in their own way. Which one, did anybody pick number 1? Explain how the principle of superposition depends on the principle of original horizontality. Did anyone pick that one?
I did. Someone didn't do it.
Okay. So let's talk about this. How does the principle of superposition, let's first review, what is the principle of superposition? So go back to the notes, which we just were looking at. Well, that's principle of original horizontality. I did ask first for superposition. Okay. All right, I think I heard a bunch of people say it now. Superposition. Oldest layer on the bottom, youngest layer on the top. What is principle of original horizontality, which I already heard some of you saying? Originally horizontality. What is that one trying to tell you?
Yeah.
Okay, so that one says they're originally horizontal. So if I had, and I'm just trying to whip up these layers here real quick. So if I had those layers. Okay, so we have these layers with this purple layer being the bottom and the pink layer being the top. Which one's the oldest? The purple layer is the oldest. That's principle of superposition. The oldest layer is on the bottom. What if the rock layers were like this? And I asked, which one's older? The pink one or the purple one? What if you didn't see the flat ones before? Then you wouldn't know. So if you just walk up to rock layers that are completely tilted like this.
Seniors are returning to class, and seniors are returning to class. Thank you.
So if you just walked up onto a bunch of rock layers that are tilted on their side like this, can you decide which one's oldest and youngest? No. So then answer the question. How does principle of superposition rely on principle of original horizontality? Yep, so I would add to what you said, Logan. You were right along the right lines, and I knew what you were talking about, but if that was the Regents question, you wouldn't get it. Or you wouldn't have got points for it. if you did not do this first box, which by the sounds of it, most of you didn't, do it now. So it's set, and just like you guys were saying together, without the layers being horizontal, you can't tell which one's oldest. Or which one's younger, either way you want to write it. I don't really, and I should have changed the wording of this second one. Do you consider any alternatives to the law of superposition? I guess I should have said, are there any exceptions? Are there any exceptions to the law of superposition? Describe them. Is there a time when the rocks don't follow the rule of oldest being on the bottom and youngest on top? There are. I still can't hear that last part. Okay, so when rocks get broken and moved, what's that called? Erosion can mess it up. So erosion can move, or I guess slash remove layers. So that'll mess up some of the ages. What were some other times? When younger rocks, what? Faults. It's faults. Folds. And tilting can mess up the order. And there's one more time that we talked about already where older rocks may end up on top of younger rocks. We actually already even talked about it today. Flip back to your drawing.
Yeah.
Which one has an older rock on top of younger rock? Is it an extrusion or an intrusion that might end up intrusion? In this case, can you stop, please? A, B, C, and D were there, sitting around, chilling, when the intrusion came through and intruded. Do you guys know what the word intrude means?
Go inside.
Yeah, to butt into someone's conversation, or like if you guys are having a conversation and I butt my way into it, that's me intruding in your conversation. So the same thing is happening here. They're A, B, C, and D were sitting there hanging, chilling, and then the intrusion butted its way through. So in this case, the youngest rocks are actually the intrusion. And so an intrusion is younger than the rocks it touches. And how about this last one? How does the age of a fault compare with the ages of the rock layers it goes through? What did I do with my, oh, there it is. So here we have some rock layers. What's a fault? The break. It's not erosion and weathering where it breaks just pieces of it. A fault is when the layers get completely broken. But what causes these? earthquakes or plate tectonic motion. How does the fault, the break, compare to the age of the rocks? Is it older or younger? Huh? Fault is younger than the rocks. The regents will then ask you, how do you know? Don't overthink this. How do you know the fault is younger than the rock? You can't break a rock unless the rock is there. So how do you know the fault is younger? Because the rocks have to be there to be broken. Fault is younger than the rocks because the rocks have to be there to get broken. And finally, how is geological history like a pizza? I know a whole bunch of you started off with it has layers. That's one way. But I need more than that. How do you make a pizza?
Toppings.
You start with the topping.
So,
The dough.
It's youngest.
So the dough, yeah, oldest. The dough gets put down, then what happens? Okay, you let it sit for a little bit. Then sauce, then cheese,
And the topping.
then the toppings. Have you ever made a pizza starting with the toppings? You did? So you put the toppings down first? So then you're right. It could be, I would call it more like could even deep dish have a crust on the bottom. You could make a pizza starting with pepperoni or peppers and onions, and then the cheese, and then the sauce, and then the crust. Then I'm going with it's not pizza. You're not picking that up and eating it by the slice without flipping it over. You could eat it with a fork. It'd be like a pizza casserole. Probably tastes amazing just the same. But to make an actual slice of pizza, you have to start with the dough, then the cheese, or then the sauce, then the cheese, then the topping. So you have to start from the oldest. So again, oldest, and I know the pizza crust is not that much older than the toppings, but technically it is because the oldest layer is on the bottom.
Well, we're still talking about layers.
Yeah, that's what I said. It wasn't, by me saying it wasn't it when you guys said layers, it wasn't all of it. You were good. It does have layers, but you needed more details to tell me how it was. All right.
How about how it cuts off the
No, I mean, it could, but the key is, because it doesn't always have to.
Not that.
Again, it's not it. Not it. That's not it.
It's not that.
All right. You do have homework. We're not done for the day though. So your homework is there's total of 7 Regents questions on pages 17 and 18. What I would like you to do now is grab page 21 and gently rip 21 out so that everything else stays in your packet. And we're gonna take page 21 out like this. I did also ask you to pick out your reference table. I actually need your real reference table. Okay, so you're gonna need out, not just your pages 8 and 9. It's good. Yeah, that one's an easy one. Anybody else need a stapler? Paste your packet, bro. So page 21, you just carefully ripped out, and you do need your reference table out as well. When you look at page 21, what are you seeing here?
Words.
Layers. Layers of rock. So again, this is much like the Play-Doh we made. This is like a side view. Like you cut into a mountain and you're looking at the side view of the layer. Now, this one has a key. I am actually very surprised. I should take the key out. There's no reason for me to leave the key. So if the key didn't exist, for example, if it just looked like this, do those symbols look familiar at all?
Yeah.
No.
Where do those
Exactly.
look familiar to you?
When we get
Good, when we did what?
late,
Not the plate stuff, that shouldn't be it.
Page 15.
The rock stuff. Pages 7, yeah. So when we did the rock stuff, so everybody turn their packets, no, not their packets, your reference table. Turn your reference table to page 7. Page 7 is the rock chart. When we were learning about the rocks, I pointed this column out and said, we do not need this until chapter 6. Here we are in chapter 6. So this is now when you're going to use this last column here. So this again, it's the map symbol. It is not what the rocks look like. My best example is limestone. There are no rocks that look like bricks. But on the regions, instead of labeling them, they will make any rock layers they draw that they want to represent limestone, they will represent them with bricks. Every single one will be the exact same symbol that's here. For example, you can see this top layer. Top layer matches up right. It's similar to conglomerate, but in this case, that top layer has those sharp pointy edges. That's breccia. The bricks, again, are limestone, not to be confused with dolostone. Those are like the pushed over bricks. What about this layer? What do you notice about this layer? What is this symbol representing? Is it sandstone or siltstone or shale? How do you know it's siltstone?
It has the dots in it.
Dashes and dots. Not just dots, that's sandstone. Not just dashes, that's shale. But a combination of the two, that's siltstone. This next one down, what do you say this one is? That's sandstone. That matches up with just polka dot. And this one is shale. Ooh, what about this one?
Breccia.
No.
I think conglomerate.
What's different? Why is this one not breccia?
It has big old rounds.
Okay, round stones. And again, conglomerate has those round fragments.
Yeah.
Do you see this symbol though? This is not listed anywhere on the keys here. If they ever have that, they will tell you, just like they did here, that that is a basalt intrusion. And the little lines around it, again, is contact metamorphism. So what you see here is the rock layers with an intrusion going through them. Again, how do I know this is an intrusion and not an extrusion? Okay, it doesn't go to the surface. That's your first clue, but that's not good enough. So you have to talk about the contact metamorphism. The fact that there's contact metamorphism around the whole thing means that all those layers were there first and then got burned by the intrusion. If it was an extrusion, it would be bald on the top. There would be no little marks there. And then what's this black line then? The fault, it's a break. So it broke all the layers. If this was a Regents question, those of you doing your homework, pay attention because this will help. If this was a Regents question, I got shot. This other part, so that heads the face. The Regents would ask, what's the oldest layer? The bottom, what's the problem with this though? There's two different rocks on the bottom. Now, I'm sure most of you have better imaginations than I do. But me just glancing at this, I struggle to see which one truly is on the bottom very quickly. And maybe you don't, but maybe just take some time to relax and color with me. So there are colored pencils scattered around the room, and not everybody got some. So you will have to share potentially with the people next to you. The order of the colors do not matter to me. So what I wanna do is we're gonna color code these layers. So grab a colored pencil. I don't care which one you pick. And we're gonna color all the shale. You do not need to color the key because we're gonna actually ditch the key. So we're gonna start with all the shale. Again, shale is the dashes.
Any color?
Yeah, any color. So if you do not have colored pencils sitting at your desk, grab one from the person sitting next to you. So notice this shale. I go up here to find the rest of the shale. Do not color the intrusion. That's its own rock layer. If you go outside of the lines, that's okay. We're gonna cut them off, I think. If we end up with enough time. So you should have colored the shale. Notice they do not match up. Why do they not match up perfectly?
Because what,
Because the plate tectonics caused a fault. Once you're done with your layer of shale, we're gonna color the layer of sandstone. And I think you probably get the point. You can just keep going. So even though these layers aren't lining up perfectly, what I want you to realize is that no matter, even though they're not lining up, the layers of shale, they're the same age. The layers of sandstone, they're the same age. When you've got all your layers colored, then go back in and color the intrusion its own color. I did skip the conglomerate. I was just gonna leave that layer white, but if you're not good leaving it white, I can deliver one more colored pencil to you. I'm gonna color that one brown. If you wanna leave it white, you're more than welcome to leave it white.
Thank you.
Any, hi, Morgan. Mrs. Rich, are you going on vacation? No.
Good.
You would be redoing her kitchen. Fine. There should have things that nightmares are made out of, as an adult. All right. So I think we're running out of time, so I'm not sure everybody's gonna get a chance to do this. In fact, how about I just. Yeah, I'll just do it up here. So what the Regents is going to have you do, like I said from the beginning, they're going to ask you which layer is the oldest, and you're gonna get to a picture like this one, and you're gonna see that there's two different symbols on the bottom. They're still gonna ask you which one's the oldest. You're going to have to basically visually, without actually doing this, you're going to have to put them back together the way they're supposed to be. So what I mean is you're going to have to take the layers and in your imagination, unbreak them. And if you unbreak them and line them back up, and of course it doesn't perfectly. Well, it's not quite perfect, but it's pretty darn close. When I cut along that break and unbreak them and put them back together the way they used to be before they got broken, oops, can't even see the rest of them. Now can you see which one is on the real bottom? You can. And that's going to be the one that's the oldest. So what I need you to do is in your packet, flip back to page 19. So what you'll see on 19, I gave you the exact same picture, just smaller. What they're going to make you do is put these layers in order according to youngest to oldest. And what they also include is event. And by event, that is going to mean like the break or the movement or the intrusion or extrusion. So we're going to start with the real. So again, they want to go from, I actually misspoke, oldest to youngest. So we're putting them in order that they happened. The oldest thing would have happened first. The youngest thing would have happened last. So what's the rock that happened first according to our coloring? Conglomerate. So you will write that in. Ooh, if I remember correctly, I think we need one, maybe not. I might not have the right number of boxes. We'll have to find out. What happened after the conglomerate? So we had the conglomerate sitting here hanging out. Then the shale. What after the conglomerate and shale were sitting here hanging out? Then the sandstone came next. After the sandstone was sitting there hanging out, what happened on top of it?
That's in limestone.
So we have the sandstone, my purple layer.
Oh, siltstone.
Then siltstone, followed by the limestone. Then what? So after the limestone was sitting there hanging out.
Limestone.
No, after the limestone was sitting there hanging out. So we already wrote down limestone. We have this layer.
Breccia.
How do you know it wasn't this red layer?
Oh, it is the red layer.
No, it's not. So limestone was sitting there. Limestone was sitting there. Then breccia was formed on top of it. What happened after the breccia?
Intrusion.
Then the intrusion. And again, Brennan, how did you say you knew it was the intrusion came after?
Contact metamorphism on the top.
So notice the breccia has these little marks on it. that has contact metamorphism on it. So contact metamorphism is like a burn. That means it had to be there to get burned. Followed by, I have one box left. What do you notice weird on the top of the Brecca? Oh, wait, I'm sorry, before that, we forgot to include, because remember, they don't look like this. They look like this now. What happened that we did not include?
The hairy thing.
The hairy thing, it comes, so you could do this, but the A, which is the fault. Oh, no, A isn't the fault. But what happened is the fault. I'm sorry. So that break happened after the Brecca. How do I know the break happened after the Brecca? Because the Brecca's broken. So then the fault was last. But there's actually one more thing. What do you notice on the top of Brecca? See how that's not a nice straight flat line? What happens on the surface of Earth that might prevent it from being a nice flat line? That's going to be erosion. So you do need to be able to put all these rock layers in order. As you can see, there is a whole second part of this that we will address tomorrow. You do have homework. There are 7 Regents questions that all go along with exactly what we just did. So those will be your homework. Make sure you actually try them and not just circle answers, because you need to understand this stuff.